Let's take a look at an x86 SSE2 instruction that will convert a packed integer value into packed double precision floating point values. In this program, I have an integer array that has two elements, and the array is initialized to 13 and 12 as its two elements, and our task is to convert each of these integers that appears in the I array into double values and populate the converted double values in the D array. So let's see how we would go about accomplishing that. So here I have a description of how the integer array and the double array would look like in memory. So the integer array has two elements, and each element is 4 bytes since it's an integer. So we see that index 0 here occupies 4 bytes in memory, and the next element, index 1, occupies the next 4 bytes in memory. The double array, on the other hand, has the same number of elements, which is 2, but each of those elements, since it's a double element, it occupies 8 bytes in memory. So index 0 will occupy bits 63 down to 0, and index 1 will occupy bits 127 down to 64. So in order to convert the integer array elements into double values, we are going to use this instruction called as the convert packed int to packed double instruction. The mnemonic is CVT PI to PD, and the specification is shown here. The way to remember this mnemonic is by thinking of the first 3 letters as CVT, as short for convert. Then you have PI, which is the packed integer, and this instruction converts packed integer to packed double, PD, and that's how you would remember the mnemonic. The operands for this instruction are given here. The destination operand is an XMM register. The source operand can either be an MMX register or an 8-byte memory location. And in this case, it must be clear that we will be using the memory flavor of this instruction, because our input is going to come from the integer array, and we are going to specify the address of the first element as an operand to the convert instruction, and 8 bytes from that would include both elements of the array. So when we execute the convert PI to PD instruction with the operand as the address of the first element in the array, both elements are converted to their corresponding double values, and these values are populated in the destination XMM register of our choice. So you can use any of the XMM registers that are available to you. Typically, if you are on a 64-bit machine, you should have 16 XMM registers available to you from XMM 0 through 15. And if you are on a 32-bit machine, you should have 0 through 7 available to you. Now, in this case, I'm just assuming that the intermediate result of the conversion goes into the XMM 0 register, and as you can see, the XMM 0 register is a 128-bit wide register. The first 8 bytes then have the first element of the integer array, which is converted into double, that occupies the first 8 bytes, and the next 8 bytes is occupied by the double version of the next element of the integer array. So now, after we have the results in XMM 0, now we have to somehow transfer this value into our double array, which will be where the final result will reside. So the way you do this is by using the move DQU instruction. So the specification for the move DQU instruction is here. The move DQU instruction, as you can see, the source operand is an XMM register, and the destination operand can either be an XMM register or 128-bit memory location. So in this case, we are again going to use the memory flavor of this, since we want our final result to reside in the double array. So we specify as an operand to move DQU the address of the first element in the double array. So the move DQU instruction then transfers the lower 8 bytes into the first index of the double array and the next 8 bytes into the first index of the destination array. So now we've reached a point where our results are converted and the results are available in the destination array. So in short, we have had to use only two instructions. One was the convert PI to PD, which did bulk of the work, and once we had the result available in a temporary XMM register, we transferred those values from that XMM register into our double array. So now let's go back to the program and start coding what we have discussed. So let's start with the input and the output list first. So the input list, we know, is going to come from our integer array, and it's the address of the first element in the array. The constraint is going to be M, since it's coming from memory. The output again is going to be in memory, and the variable that we are going to use is the first element of the double array. So now that we have the input and the output list ready, let's start coding the two instructions. So the first instruction we use is the convert instruction. So we use convert PI to PD, and we saw that the destination register was going to be an XMM register. So let's just use XMM1 in this case. So I use XMM1 as the destination. The source operand comes from the integer array, the 8 bytes that come from the integer array. So that is denoted by the placeholder %1. So after this instruction executes, now at this point conversion is done and result in XMM1. So we have the result in XMM1. Now we move the value in XMM1 to the destination location, which is the double array, and I'm indicating this with the placeholder %0. And once this is done, we should have the result available in the double array, and the program then just iterates through the double array, displays each of the two elements, and it terminates. So if the conversion process went through fine, we should see a value of 13.0 and 12.0 being displayed by this cout statement here. So let's first build the program, and let's run the executable here. And as you can see, we get a value of 13.0 and 12.0, which are the double values for the integer elements from the integer array.